Okay, my name's Paul Herford. I've been with Symbol, Motorola Solutions, Zebra for about the last 20 years. So I've sort of been developing software all that time. Some of you might know the name because originally I wrote SimScript. I don't know if anyone here knows, was heard of SimScript. Okay, so originally I wrote that, so that's how you might know the name. There is an Android version in the pipeline. It's in beta at the moment, so I suspect in 6 to 9 months you might see a lot more of that. It's a lot better. So today I'm going to talk about the JNI, the Java native interface, and calling C, C++ code in your application. Okay, and reasons why you may want to do that. And I'm going to use the MQTT protocol as an example, because I had a recent project where I had to basically get data from a terminal and from a server to the terminal in a fairly efficient manner across a large number of terminals. And I was looking at how to do it. And MQTT came out to be a very good protocol to use. And I must admit, it is very simple. It's very easy to use. It's cross-platform. It runs on basically everything, and you get clients for everything. So I basically got a C++ library from the internet, the FAO library, and ported that to Android. And I now use that on Windows, and it will port to other platforms quite easily as well. So I've got one library which is cross-platform, and I did that on Java using the JNI. So I'm going to go through and use that as an example and talk about MQTT, why you may want to use it, the advantages of it, etc. So. That's why. I'll go the right way. Come on. Okay. So really, I'm going to talk about what is the JNI, why use the JNI, and also when not to use the JNI. The JNI doesn't solve all your problems. There are times when you don't want to use it. MQTT, what is it? A brief overview. And I'm going to go through some basic JNI examples, just enough to get you started if you want to experiment with it. And also some of the pitfalls that you can come into with the JNI. Okay, so what is the JNI? Really, the JNI allows you to call C, C++ code, or even assembler from your Java application. The JNI is the interface that you go between the two languages. So typically on your C side or C++ side, you've got functions, you've got libraries that you'll be calling. And on the Java side, you've got exception classes and your virtual machine. So the JNI is the glue that basically holds those two together, the interface at which you go through to pass data from your Java into your C side and vice versa. Because from within the C side, you can also call Java functions as well. So if you want to implement, say, a callback in your C++ into a Java function class, you can do that as well. So it's quite useful on the MQTT. So when a message arrives, I can do a callback onto a Java class to say a message has arrived. So we'll cover that. So the JNI is cross-platform. It's not unique to Android or the Dalvik JVM. It basically runs on any JVM, or any JVM should support it. It is a standard. So if you write your code once with the JNI, it should run on other JVMs as well without any problem at all. So it is portable across the Java world as well. So on Windows, you would have DLLs. On Android, you've got shared objects, the SO files. So, okay, why use the JNI? Okay, there's lots of good reasons why you would want to use it, and probably some why you wouldn't want to use it as well. Okay, portability, C, C++ code is probably the most portable code in the world, I would argue. You can write some C code, and it will basically run on multiple platforms. Okay. And you can guarantee that if a new operating system comes out in the future, almost certainly it will be written in C or Linux, and you'll be able to run C libraries on it. So, and also C's been around a long time as well, and it runs on all the current platforms. So if you want some code to run on Linux, Android, iOS as well, Windows, or whatever, the C++ code will run on it. It could also offer significant speed improvements as well. If you want something which is speed critical, maybe you're doing some video processing or whatever, or some complicated maths, C can actually offer you quite a speed improvement over Java. Okay, because obviously it's compiled natively. There's no garbage collector either. Okay, so you have to do all that yourself in C++, but you obviously get a speed benefit from it as well. You could also access the hardware. If you're doing a project where you want to access the hardware directly, obviously with C, C++, you can do that. With Java, you won't be able to do it. You can reuse existing libraries code, which is exactly what I did. There's a huge wealth of C++ libraries out there that have been written over the last 30, 40 years. So you can reuse those, and you'll probably find that most of them, the more popular ones, already have a JNI interface already written for them. You can also use, if you use C, C++, it's not just Java you can use it with. So you can also interface to other languages like .NET as well. So if you write a C library, you can access it from other languages as well. It's not just Java. Although obviously the interface will be different in .NET, it'll be a p-invoke, whatever, and not the JNI. But you can still use that same code base. And also it helps to protect your IP. It's quite difficult to reverse engineer a sort of native library, a C library. Okay? Unlike Java, where it's quite easy to reverse engineer it, there's lots of tools out there. So it does help protect your IP if you're concerned about that. I tried to get some stats on how many of the popular Android apps use the JNI. I couldn't get any actual stats on it, I did try, but looking through the logcat on a few applications, the popular ones, they all had a JNI component. So things like Waze, etc., all had a JNI component behind them. So you'll find a lot of the popular apps actually use the JNI interface, probably for code portability, code reuse. Okay, so it is quite widely used, but you may not be aware of it in your day-to-day world. Okay, when not to use the JNI, this is quite important. The JNI doesn't solve everything. It does have some drawbacks. There is a significant overhead in going through the JNI from the Java to the C, through the JNI layer, through the interface layer. It is quite processor intensive, okay? So if you're only making a few Java calls across into your C++ library, it's fine. And there are some techniques, which I'll mention later, that you can use to try and improve that performance as well. So it's not just a case of just writing C++ code because you can. Obviously, you want a reason to use it, code reuse, performance, or whatever. So be aware of that. You also must compile the code for each platform OS. So you've got 32-bit, 64-bit, and different platforms which you need to create the library for as well. So it's a bit more work in that respect. So obviously when you set your build up, you need to be aware you need to build for different platforms and different processor types. So it can be a lot more work in that area. Also, when you're writing your code, you've also got to take into account the OS specifics of the target platform you're writing for. Obviously, you've got Linux, Windows. They are similar, okay, but things like the threading, thread synchronization, your mutexes, locks, mutex locks, critical sections on Windows. So you have to be aware of that when you write your code. And if you're aware of it when you start writing your code, it's not too difficult. You can just use hash defines, if defined, whatever, depending on the platform type, and implement the appropriate code for that platform. So you might have a class called lock or something, and you can encapsulate that inside a class. And then, depending on what definitions you've got defined in your preprocessor, you can code for different platforms quite easily, whether it's Android, iOS, Windows, or whatever. And it's not too much work, but you just need to be aware of it and build code around it. Okay, so I'm going to quickly mention a bit about the MQTT protocol. Is anyone here using it? Okay, one person. Okay. It is, I would say it's not new. It's been around about 20 years, I believe. I think IBM basically used it in their WebSphere suite of software. So I believe it's about 20 years old, but it's only really, in the last few years, starting to become more mainstream now with the Internet of Things, because it's a great protocol for the Internet of Things, okay? It's fairly lightweight, it's quick, and it's efficient, and it's very easy to use, and it's very easy to debug. And it fits quite well in with the mobile world as well. because of the way it works. So it's a publish-subscribe mechanism. So a client will publish, okay, and a client can subscribe to a message, or in their terminology, a topic. It is a standard now. Okay, so all you really have is a payload and a topic. The topic really identifies the message, the structure. Okay, payload can be absolutely anything you like. It's just a set of data, so it could be JSON, XML, binary. It's entirely up to you how you want to use it. And I believe each payload can be up to 16 megabytes in sort of data. So I'll just mention a bit about the topic. The topic can really be anything you want, but you can design, but ensure you design your topics carefully so that you can target different groups of devices in different areas. So what you could do is you could have a topic like that: world, country, town, store name, location within the store, warehouse, back store, front store, whatever, the model type, and also the serial number of the device. So with that topic, you can target, if you send that full topic, you will target just that device, assuming that the client is subscribed to those messages, or you could target all the TC5 or the TC75s at a given location, depending on how you publish the message. So in our world, we tend to have a group of terminals in a store or warehouse or whatever at a certain location. You can send a message that will target a specific store within a location, or a specific device, okay? So from that perspective, it's very powerful. So within your software, you could publish one message, say to the world, and that would get broadcast to absolutely all the clients at once, okay? And you can break it down. So from that perspective, from my project, and generally the sort of projects that we get involved in our world, the enterprise world, it works very well, that topic structure, because you can address one terminal or any location. So if you wanted to, you could address all the terminals in a given country by just broadcasting one message. And the payload could be anything, but typically it would be JSON or XML, really, passing it down. And of course, all this can be encrypted as well. Okay, so when you're starting the project, what I typically do is run it unencrypted. For debugging, it makes it a lot easier. There's plenty of tools to help you debugging. I'll show you one later. But it's a very, very simple protocol to debug. Okay, and then you can encrypt it when you get ready or nearer to release. The clients connect via what's called a broker. So the broker sits in the middle, in the cloud or wherever, and the clients connect into it. So the clients aren't directly connected together, they're connected to the broker. So that means you can work with netted IP addresses quite happily as well, because the client's connecting out into the cloud or wherever. So there's no issues with firewalls or anything like that as long as the ports are open. So again, that's very useful. So it works in the cloud, it works locally. It can work on your hosted infrastructure or whatever. So you can publish one to many. So the client, which could be a temperature sensor, say, could publish out, and there could be multiple clients receiving that published message as well. Okay, it's very powerful from that respect. So if you had a sensor with multiple computers that wanted to receive that data, it's very easy. They just subscribe to that topic, and the temperature sensor would publish that topic. And they would, when the client publishes, the ones that subscribe to it would receive that message. So it's very good. And it also supports several quality of service levels, which I'll come to in a bit more detail at the moment. I tend to only use the quality of service 0 and implement my own ACK protocol because it's easier, and I don't want to generally load the server. Because typically you might be working with tens of thousands of devices, so you want to keep it as efficient as possible. And each client has a unique ID as well. So every client connecting to the broker has to have a unique ID when they connect. If you try and use the same ID twice, one of the clients will be dropped. Okay. So generally a GUID is a good ID because it's almost guaranteed to be unique. So that's what I tend to use as a GUID for each client. Okay. It's just to identify internally really for the broker. It doesn't really have any influence on that, because you can normally identify the terminal from your topic by, say, embedding the serial number of the terminal in the topic. Okay, so this is a simple example. So we have a temperature sensor, the broker somewhere in the cloud, and we've got a couple clients. We've got a mobile device, we could have a laptop, or whatever. So when that temperature sensor publishes a message, the clients that have subscribed to that topic that it's publishing on will receive that message. Okay, and it's also very, very quick. Okay, typically when it publishes it, a few hundred milliseconds later, you will get the message. Now, one of the big users of this architecture is actually Facebook. Facebook Messenger is based on this protocol. Okay, and the reason they did that was basically performance, speed, because it's very light, it's very efficient, and very quick. There's absolutely minimal latency. It's only really the latency on the network. So it's very quick. So you could broadcast one message out from that temperature sensor, and all the clients will typically get it within a few hundred milliseconds. And conversely, these could also, if they wanted to, publish, and the sensor also could receive it if it was intelligent, maybe to change its settings or whatever. Okay, so I just mentioned a bit about the quality of service and something called the last will and testament. Okay, this is quite a useful feature. Okay, I'll mention about the last will and testament first. Basically, this is a mechanism that allows you to be notified. So if you're subscribed to a particular topic, i.e. a client, the last will and testament will basically, it's a mechanism to allow you to get notified when that client disappears. So on a mobile device, the battery could go flat, so that client's no longer connected to the broker. After a period of time, when the broker's decided that device is no longer there, it will actually send you the last will and testament message for that terminal. So what would happen is that the client, when it starts up, would tell the broker what the last will and testament topic it is and the message. So when you subscribe to that topic for that device, when it disappears or for whatever reason, you get notified with that topic, by that topic and that payload. It's preset. So if you have terminals that basically go to sleep, suspend, flat batteries in the field, you'll get a last will and testament message more or less of when that event happens. So you know the device has disappeared. So if you've got, say, a console where you're monitoring devices, it's a mechanism to allow you to see that they've disappeared. Okay, so that's quite useful. And it also works the other way from the broker to the clients. So the broker can set up a last will and testament, which the clients can subscribe to, so they will know if the broker's basically disappeared or gone down as well. So it's quite a useful mechanism if you need to know if the device is connectable. Because obviously you can send the message to the publisher message, to the broker, but you won't know necessarily at that point if the client received the message. So this is where the quality of service can help as well. So, as I said, I normally do everything at quality of service 0. This is the lowest quality level. It's basically fire and forget, and it relies on the TCP/IP mechanism to get the message across. So it will use the TCP/IP retry mechanism. So it's the lowest level of quality, but it's also the lowest overhead in terms of performance. At least once means that the client at the other end will get that message if it's connected at least once, okay? But it may get it more than once, okay? There's no guarantee that it won't get it more than once, so it will have to handle duplicate messages. So if it's putting data into a database, it needs to be aware that it might get that message twice, and it will have to handle that duplicate message. And the highest level of service, and obviously the slowest, is the quality of service 2. It has the most overhead, but it will guarantee that that message will get to the client only once, but it guarantees delivery. There's also a persistence flag, okay, for quality services 1 and 2. So if you publish a message with a payload, and the quality of service is 1 or 2, and the subscribing client, when it connects, is on that quality service level as well, it will get the last payload from that device. Okay, you may think, well, why is that important? It's old data. If you've got, say, a sensor which doesn't update very often, you may get a sensor which only updates once a day. It means when that client connects, it will get the last data from that sensor automatically without the sensor having to do anything. So the sensor's published its message with a persistence flag set. That's stored on the server, okay? So when a new client connects in, it will get that last payload because of the persistence flag. So that's very useful if you've got sensors which don't update very frequently, maybe once a day. But if you've got sensors which update frequently, you wouldn't want to do that because you're going to get a new reading fairly quickly. Okay, so some of the libraries that I've typically used, is the FAIR library. It's quite a good library. It's comprehensive. It's C++, but they also support other languages, JavaScript, PHP, etc. So it's a great place to go if you want a client library for. And they also do Android services as well, Java clients. So it's a great place to go if you need a client. It's basically written by IBM, and they've basically open sourced it. And you've got, for a broker, you've got the Mosquito library. They give you a broker out of the box. That will run on Windows and Linux if you want one. So it's very good for testing. If you want to set your own test system up, the Mosquito broker is very good, very easy to use. And also there's Hive as well, which is, some of it's free, some of it you pay for on there. So you can get brokers, clients for virtually any OS. So in terms of setting up a quick solution, you can get off-the-shelf libraries in almost every language that you want. Now, just to show you how easy it is to debug this, I'm going to use the FAIO tools just to show you a quick example of how easy it is to debug. So if I can just quickly... Okay. So this is the FAIO Eclipse plugin tool for MQTT. So I've just connected it to my home server where I've got a Mosquito broker running. And effectively, it allows me to eavesdrop on all the messages going into the broker because you can subscribe to the same topic. So I have an app on here which is talking to a server, but we're all using the same broker. So if I subscribe to the same topic, in this case, I've just subscribed to zebra slash hash. So that means basically a wildcard. So any topics that start zebra, I'm going to basically receive into here. So very instantly you can see, as soon as I switch this on, I'm getting some messages come through. So if I just send a test message, okay. As I subscribe to everything, I get quite a few messages. So I'm just pressing here, test, and you can see it's coming up on there that quick. That's typically how quick this is. It's a few hundred milliseconds. So that's gone from here to my home, and back to here effectively, through there. So these tools make it very easy to see what's going on. So you can see what messages your client is sending, what topics, etc., and you can see the payloads. I mean, this is currently unencrypted, so it makes it easier. If it was encrypted, it shouldn't make too much of a difference as long as you've got the certificates on there. Okay. So it's very easy to debug and see what is going on. So I don't even need to look at my code to see what topics are going backwards and forwards. I can see it from there. So if you've got terminals in the field, remote topic clients, as long as you don't know the topic of that, you could target that device individually by having the full topic if you wanted to. So any issues with it, you could hook into something like that tool and see what was going on very easily. So it's very easy to debug. Any questions on MQTT? I mean, I don't know how you find it.
Just tried it out actually with the Mosquito server.
Yeah.
Just made a simple messenger.
Yep, it's great for that. Yeah, it's great for that sort of sending messages backwards and forwards.
Yeah.
So if you've got a client application out in the field and you want to send, say, the user a message, it's a great protocol for that sort of thing. It really does work. It's very light and it's very efficient. Okay, so other things you can do with it. I don't know if anyone here is into home automation. I don't know. But I've started experimenting with these sort of things. These are sort of a plug. It's got a small 32-bit microprocessor in there, okay, and an access point. But what you can do is you can get an MQTT client for these as well. So you can set up a topic on here. The sort of thing you can do now with this, you can define a topic. So like front living room, light or whatever, plug. And you can actually hook it into Alexa quite easily as well. So if you want to play about home automation and Alexa, you can use something like OpenHab as the interface, and when effectively Alexa, you're speaking to Alexa, send a message, it gets routed through to OpenHab, you can get that to send an MQTT message to something like this, to control the socket, light, whatever you want. It's very, very easy, and that's using MQTT. So hooking into Alexa may not be as difficult as you think. It's very simple with something like that. And these are about, I think, about €8 each. And you can get little inline modules as well for less than that, I think about €5. So if you want to control something, it's great for that. So you can talk to Alexa and control that. So with something like MQTT, with a very simple client on there, which is all open source. So there's a lot you can do with it. Okay, so we've worked out we're going to use MQTT as protocol. We've got our library. We've ported it across to Android. It's compiled. So now we need to access that from our Java application or whatever. So for the JNI, you basically need to get the NDK installed. If you're using Android Studio, when you use the C++ component, it should download it automatically for you. So the NDK is really the platform libraries and the C runtime stuff. So the typical compilers you would use, obviously, are Android Studio, which you can write code for. But another option is Visual Studio from 2015. From 2015, it has cross-platform support in it. So if you create a project, you can create a cross-platform project, and that will allow you to target iOS, Android, and Windows. So you can have one code set that will compile into the required libraries on those three platforms very easily, and it will create the shared libraries for you. So you can use the JNI library in your code directly, or the better way to do it is to actually have an AAR file or a jar file that wraps it up, and then you can easily just drop it into other projects. Again, it's very easy to do. So with Visual Studio, when you create a new project, there is a cross-platform option. So if you select that, you can target Android, iOS, and you can also create projects for Windows as well. So Android Studio will allow you to create it for Android. Okay. So if you want to run on other platforms, Visual Studio may be a better platform to go for the compiling. And also from the managing the project as well, Visual Studio is a lot better. It's very easy. It's just, if you're used to Visual Studio, it's drag and drop the files in, okay, and it basically manages the makefile, the build behind the scenes for you automatically, okay. In that respect, I think it's probably better than App Studio, or Android Studio. So the typical structure will be you have a shared directory where all your platform code goes, you write everything in there, and then anything specific, you've got your iOS and Android directories in there as well. Okay, so with the JNI code, so the JNI is actually very powerful. The more you dig into it, the more you find you can do with it. It's really powerful. So Java can call C++ functions quite easily. So in the MQTT example, you might have functions to connect, initialize, publish, subscribe, and a shutdown close function. So they're the sort of functions you would have that you would write in the JNI. So there's only a handful of functions you need to implement the functionality. So you need to expose the functions in the JNI into the Java so it can call them. So if you research this, you'll see a lot of examples in the function name give fully qualified function names, okay? Package name, class name, function name. So you end up with a huge function name, which can be, difficult to follow, difficult to read, but there's actually a much better way. There's a function called onload. Onload gets called when the shared object, DLL, gets loaded into memory. And in there, you can load your functions or register natives, okay? That means you can keep the function name as you would normally. So when you call it, you register the function on the onload. On the onload, you can also put debug statements as well. So you know the library's been loaded, you can put whatever you like in there. Each function has a signature, and this has to be perfect. The signature has to match the function parameters exactly. If it doesn't, the onload will fail, and the registered natives will fail. So it's very important that you understand the signatures, how to do the signature. So like a string is actually an object class, so you define it like that. The other parameters are primitives like the ints, the shorts, the floats, the doubles, and they sort of map almost one-to-one. But things like strings are treated as objects. Okay, so you have to declare that slightly differently. And obviously you can have arrays of these as well. So the onload typically is C++ function name, the signature for it. So anything in the brackets is the input, after it, it's the return type, and that's the actual function it's going to call. So you pass that into the API register natives, and it will either load them or it will fail and return you an error. So once you've done that, you can then write your C++ code. So this is an example of publish. So we're passing in a couple Java strings. When you pass, say, Java strings into the C++, you can't use them directly. You have to convert them to a C-type string, okay? So getStrings UTF-chars will convert the Java string into a C string that you can use. And this is really important. After you finish with it, you must call release strings. Sorry, release UTF-chars. If you don't, you'll get a memory leak, okay? And you must always check for exceptions, because if an exception gets thrown in the JNI, okay, you come back to your C code, it won't get thrown there or executed, but you must check to see if one's occurred, and you must clear it. If you don't, it will basically get returned to the JVM, and it will throw an exception in there. So you always check for exceptions, and always check the return codes of JNI functions as well. That is very important. If you don't, you'll get odd things happening in your code because exceptions have been thrown into JVM and it will crash. So to call from Java, so this could be in your AAR file, Jar file, load system library. It will automatically put the prefix lib and .so onto the library name, so you don't need to put that into your code. You declare the function as a static native with the parameters, and then you can just wrap it and call it. Okay, it is as simple as that. You need to ensure the SO files are also in the correct folder as well. So when you build your libraries, 32-bit, 64-bit, different processor types, they need to go into the correct JNI libs folder. Okay, here. That's a typical structure there. Source main, JNI libs. Different processor types there, 64-bit, 32-bit. So you need to make sure you get the right libraries into the right folders. Okay, that is important. Otherwise, it won't find the library when it runs. Okay, so you can call. So you can call Java functions from C++. Now this is great for the callbacks, okay? So you're running your C code, it's monitoring, it's doing stuff. An event happens that you wish to notify your Java code about, like a message has arrived. Again, this is fairly straightforward. All you need to do is typically, I have an initialize function that I call from within the class. When you call that, it can get the method ID of the function, okay, in the Java class, and it stores that, it caches it. It does that for performance reasons, to minimize the number of calls you make through the JNI. And again, each function has a name and a signature. So the signature format is exactly the same as before, but it has to be exact, okay? Yeah. So to call a function, you would normally have got the method ID, okay? You've got to be a bit careful here because you might need to create a global reference to the class because those method IDs are only valid when the object effectively is there, it hasn't been garbage collected. So if you create a global reference, that will stop the object from being garbage collected. Okay, if you don't do that and it's garbage collected, you will have an exception thrown in your code and it will fail. So what you do, assuming you've got the method ID, you attach the JVM, okay? So you might need to attach the thread to the JVM if it's not already attached. You then call the function and then deattach the thread from the JVM if you weren't already attached. Okay, that's quite important, that. So this is an example of calling a message. So with MQTT, you get basically a message notification saying that you've connected to the server. So the method ID, I've already cached it on the initialize function. So I'm just basically reading it from the cache, the method ID there. We attach to the JVM. So that's basically important to make sure we keep all the threading and sync, etc. within the JVM. I then create a Java type string. New string UTF creates a Java string, and I pass in the string I want to create it from. Okay, so I created a Java object, a J string. Okay, I check for an exception to make sure nothing went wrong with that creation. Okay, if it does, you want to clear the error and probably return. And then I call the method, call static void method. So that means basically the method doesn't return anything. The reference object is one I got on the initialize, and I've got a global reference to it. Mid is obviously the function, is the method ID. And I'm passing in a connection status, which is a JInt or an int. And I'm also passing in the Java string that we've created. So when I call the Java function, okay, it will call it and pass in those two parameters to it. You always get passed in, you always pass in into the call static method, the object and the method ID. And again, you check for any exceptions after calling it, in case there was an exception thrown in the Java code, and you check for it and clear it. And then if you did attach to the JVM, you do a deattach in that sequence. And that will allow you to call a function in the Java code. You can also call methods as well, fields. So if you've got some fields declared in your Java class, you can even access those as well and update them and change them. So pitfalls, okay, with the JNI. Always check for exceptions, return codes. Always, always do that. That's very important. Right, local references, global references, you must clean these up. If you don't, you'll get memory leaks. We have a tool called RX Logger, which is on all our devices. That's a tool that, if you're familiar with SimScript, EMScript, similar logger, every minute it will take a snapshot of various system parameters like memory usage, CPU load, and 20 or 30 other parameters every minute. So if you keep that logging over a period of time with your application running, if memory's doing that and CPU load's doing that, it's useful to know as a crude check. Be aware of 32-bit, 64-bit processors if you're using ints longs, okay? Because on a 32-bit, in C, a long is only 32 bits, not 64 like in Java. So if you pass a Java long into a 32-bit processor and it's declared as long in a C, it will truncate it to 32 bits. You need to declare as long in the C code, because that's caught me out before, okay? Cache method IDs, field IDs, you can cache those and keep a global reference to the object, okay? That means that when you call them in the future, you've cached them and they're ready to use. You don't need to do find class and get the method ID each time. It's much more efficient. And if you're using several local references or creating several Java objects, but I think the default was like 16 objects in the JVM it will allow you to create in that method. If you create more than that, for whatever reason, without freeing them, you can actually increase it with that Java the JVM function there. So this is a barred example of calling JNI. Effectively, you're doing a find class, get static method, and then you're actually calling the Java function. So the two calls above could be eliminated by caching the method ID. And then you just call the method directly. Okay. So this is another little test for you. So one of these is a good example of using the JNI, and one isn't. One of these is a lot more efficient than the other. Can anyone guess which is more efficient? Whether you pass in several parameters at once and return the sum of them, say, or get the field ID from the class, which basically means that variable. So you're getting ABCD from the Java class directly. One of those is a lot more efficient than the other. It's actually the top one is a lot more efficient. You know, a factor, I think, 6 or 7 times more efficient, because here, each time you're calling through the JNI layer. So if you're writing some JNI code, think about how you do it, minimize the JNI calls as much as you can, cache the IDs. With these fields here, if you really wanted to do that method, you could cache those IDs in advance. So when you come in here, it will be efficient because you've already cached them. Okay, so in that answer, yeah, so it's quite a bit different. 3,500 milliseconds versus 600, over 10 million times. So it's quite a significant difference. So you need to be, when you're writing the JNI code, think about how often you call it and limit the number of times you call it. And cache them as much as you can. But be aware if you cache it, the global references, local references, and back freeing them as well. Okay. Any questions? It was a very, very quick overview, but it may just be enough for you to experiment, get started, and avoid some of the pitfalls that I did. So if anyone wants the source code to the MQTT stuff and the Android project, drop me your email address, and I'll email it to you.
Question, haven't you been using already this with some sensors, like with the IoT kind of configuration?
Which sensors?
With sensors.
Yes, you can do. Yeah.
Yeah, but are you planning to do something with sensors?
No, I've used, no. Well, I mean Zebra.
Yes.
No, not directly. Not that I'm aware of. I've just used this in my project to communicate with our terminals and things like these sort of devices for home automation and that. So it basically, if you have a sensor and it supports the MQTT protocol, it's very easy to talk to it. But I'm not aware of us having any plans.
Can you manage CPU affinity in JNI? Meaning, I want to target a specific CPU. For instance, on a TC51, we have 6 cores. Can I choose what to use?
What you mean in the C code or the JNI, the Java?
Yeah.
That's a good question. I can't be sure of the answer to that, but I would have thought the C code would give you more control over that. Because the JVM can limit the number of cores and the resources you can use, can't it? It's a good question. I don't know the answer to that. When you call into the JNI, whether it's limited by the JVM restrictions, or when if you create a new thread within the C class, whether or not it avoids that restriction. I don't know the answer to it. It's a very good question. I will try and find that out. It is a very good question.
Actually, when you
Yep.
You see a lot of IRQ moved from CPU to CPU
Yep.
and so on. So actually, there's something going on.
Yeah, I would. You basically with at the C layer, you can call any of the JNI stuff. So it's no real. So whether it bypasses the JVM restrictions or not, I don't know. It's a good question. But the JVM, if you create a thread, has no control over it at that point because you're down at the OS level. Okay. Any other questions? So if anyone wants any, source code for this, just let me know. And it will run on Windows and Android.
Actually, what was the reason to choose to implement the protocol using C? Because I think the protocol can be implemented in using Java.
Yep,
And it's also
right. You could write the code. You could write the protocol in Java, no problem at all. But if you want to run on other devices, okay, multiple.
Arduino or small devices are limited to C.
Yep. So
But you do not target actually such chipsets. You
right.
target,
Okay, this would run the same code if I wanted to on that. So the class I've ported, I could run that same code on here if I wanted to. I can also run that code on Windows natively as well. So what it allows you to do is have one native code set, okay, that you can run on multiple platforms. So you could write it in Java, then you're limited to the platforms that support that version of Java. And Java is not as portable as you may think.
But what about deploying on Android? You have to compile for 5 or 7.
Yeah. So when you create your libraries, you have to tick the right boxes to create 32-bit, 64-bit, different processor types and versions of the library. Normally, it's just a case of checkboxes.
Yeah, but if you'd like to use this AAR file and deploy it, let's say on App Store, then your application must include all.
Yeah, you have to. So in the AR file, you would embed the libraries for each processor, 32, 64-bit. You have to do that. Yes. Once you get used to it, it's not really too much of a problem. The compilers will throw out all the various versions of the library. You just put them into the AR file in the correct directory. So I normally just have a bash file to do that. It's not so difficult as you think, but you have to do it. You have to put the 32-bit and 64-bit versions in.
And what about some user in China brings a new Android, some device with a known CPU, some new CPU. You never know. Android can run on whatever.
Yeah, but you normally know in advance what chipsets you're targeting. Yeah. So it's possible you could get some future one, but generally the compilers throw out everything you need for all the current platforms. Okay, I've not had any issues yet. So any more questions? Because I think we're about finished. Okay, thank you.